Students value evidence. This is a capacity that educators seem to have a strong base on. We're very familiar with this in terms of writing, and when you think about extended response for an ISAT passage, we often ask our students, what in the text makes you say that? What in the text makes you write that? What makes you believe that your argument is true? It's that evidence-based learning. Yet, what we need to start to transition to is having students have conversations about the evidence, where students relate their critiques and how they've comprehended the text out loud and verbally. The next capacity is that students use technology and digital media strategically and capably. Think about any toddlers you may have in your family. Have they had an opportunity to use an iPad, a touch phone, or a computer? I think nowadays the answer is yes. So when we talk about preparing our students for 21st century learning, it's no longer teaching students how to use a particular technology tool. Now it's teaching students which tools to use and when. Which tools do they agree with that is appropriate for the specific content they're using. Our students are digital natives, and we must meet them where they are to help them learn in the future.
Speaking of 21st century learners, capacity number 7 really addresses the different perspectives and cultures that our students are experiencing. We no longer are teaching classrooms of homogeneous groups, and while as teachers we understand that we should be teaching a welcoming community where we embrace all cultures and religions and backgrounds, we don't necessarily use that integrated as part of our instruction. And we really need to not only demonstrate that we are comfortable with diversity, but give the students opportunities for them to have those critical conversations and reflect on the diversity of their peers. Hopefully you had an opportunity to reflect on the ELA capacities of a literate individual, and we're now going to move into the 8 mathematical practices that are addressed with the Common Core math standards. Really, again, this is an overarching theme that these instructional needs should shift so that the focus is on what the student is doing and what the student is demonstrating, and not so much what the teacher is doing or the teacher is demonstrating. While it's still important for the teacher to model these activities, we really want the students to be able to demonstrate their understanding of these strategies.
In a similar way to the capacities of a literate individual, the mathematical practices also start with the students first. However, they start with mathematically proficient students. So when we think about what mathematically proficient means, it's when we expect students to go beyond getting to the right answer. On the screen, you'll see several different examples that address ways that students can make sense of problems and persevere in solving them, which is our first mathematical practice. The first 3 practices will address going beyond getting the right answer and helping students develop thinking skills in order to express and communicate the way they solve particular problems. The second mathematical practice is that students reason abstractly and quantitatively. What this really means is when we think about how students get to the answer, it's through the use of manipulatives, which may be concrete, or pictorial representations, or abstract numbers and equations that represent the problem that they are solving. For example, if we take a look at 7, the number 7 as a solution, we could ask our students, how many ways can we get to the number 7? And this would require them to reason abstractly and quantitatively through concrete, pictorial, or abstract manners. On the screen, you'll find additional samples to support the mathematical practice number 3, which is that students construct viable arguments and critique the reasoning of others. One particular example that we're familiar with is through the use of exemplars, where students solve and explain their thought process, and that's one that they are particularly familiar with utilizing. Another opportunity for students to critique the reasoning of others is through math chats, where students have conversations about the way they solve the problems with their peers.
Now Daniela and I are going to model what a math chat might look like if both of us were students in a class and the teacher asked us to draw a picture to represent the formula 2 plus 6 plus 4 equals 10 plus 2 equals 12. Daniela, you want to start?
Sure, I'm the student on the left, and as you can see, I decided to break this problem up based on each of the 3 digits to find my total sum. So I color coordinated the 2, the 6, and the 4 in order to get to the total sum of 12. How did you solve the problem, Sarah?
Well, I decided to use stars today. I was in the mood. So using my stars, I started with my total, which is 12, and then I decided to work backwards. I knew that I needed to get 8, and 8 and 2 is 6, so I have 8 stars in one line, and then 4 in the other line. And so I realized that I better show the relationship of 2 plus 10, and so that's why I decided to circle the 10 stars and had 2 left over. What do you think?
I noticed that you put all 8 together and you kind of went through and explained that. I think that if I would have done that, it would have saved me a lot of time and I wouldn't have had to have drawn as many little dots on the screen. I think I'll try that strategy next time.
I think I might try your strategy because I liked how clearly you were able to identify all of your different steps. Thanks for sharing.
Thanks. The fourth mathematical practice, Model with Mathematics, comes from the NCTM practice standards of representations. Here, students are replicating what the teacher has modeled for them and showing multiple avenues for solving their problem. In this case, the teacher is not only the facilitator, but the one who is directly guiding students on how to solve the problems by modeling, by engaging in think-alouds, and applying math to situations that students truly can relate to. In the fifth mathematical practice, students truly are at the center of their learning. Students are making appropriate decisions based on particular tools to solve a problem. Therefore, the teacher provides a variety of opportunities for students to become comfortable and familiar with different tools in order for appropriate choice based on a particular type of problem. As sharing ideas becomes common practice for students, students begin to work on simplifying their explanation to particular problems. This is where mathematical practice number 6 comes into play of attending to precision. In addition to the samples provided, students also are able to appropriately use definitions and vocabulary from the Common Core standards. Here you'll see a sample of student work where students have looked for and made use of structure. For example, here you see 7 times 8 and 7 times 5 plus 7 times 3, where the student has identified the structure of this particular multiplication pattern. The last mathematical practice, students look for and express regularity in repeated reasoning, is when students find shortcuts, patterns, and repetition in math problems. For example, a student may do 57 times 3 in a traditional multiplication way, whereas they may break it up to find 50 times 3 plus 7 times 3 equals the same answer. So what the student has done is use previous knowledge of basic facts and their properties of 10 to solve mentally. We hope you've enjoyed this audio recording of Common Core Session 1. Please feel free to email us with any questions. We look forward to seeing you on February 15th to talk about shifts in content and instructional practices.